In this video, we explore the many ways in which we can get data into and back out of a database. It is important that data entered into a database is accurate. A number of methods can be employed to ensure accuracy and speed of data entry. One method of manual input is to use a paper data capture form, having a dedicated sheet with all the fields you want to collect clearly labelled. The form may instruct you to only complete with a black pen in capital letters. It may have boxes to clearly tick and squares into which you can enter each letter. This ensures that the person inputting the data is less likely to make a mistake due to poor legibility of the text. To speed up the data input, you could use optical character recognition, OCR, to automatically read text from the form. This is not just restricted to forms. The Post Office use OCR software to read postcodes and route mail. Cameras on roads use automatic number plate recognition software for congestion charging. Another possibility is optical mark recognition. This is often used for multiple choice tests and for lottery tickets. It's a very fast and efficient way of getting data into a database, significantly reducing the chance of human error. Magnetic stripes, barcodes and QR codes are also possibilities. A common query language for all databases, called SQL or Structured Query Language, allows data to be extracted from a database. To the user, an interface could be presented as a series of input text boxes, options or drop-down boxes, enabling the data to be searched and filtered. The database management system provides a layer of abstraction for the user and programmer, hiding the underlying structure of the data storage. It ensures data is kept integral by preventing duplicate primary keys, enforcing validation rules, providing secure access, encryption and program data independence. It manages many connections to the data source and prevents two users updating the same record at the same time. SQL is both a data definition language, defining the structure, and a data manipulation language. The dataset can be changed in SQL, adding tables and records, amending records, and deleting records and tables. In fact, SQL is so powerful you don't actually need an interface at all to make the changes, including setting keys, relationships, and rules. It is common to want to be able to exchange data between databases and other applications, for example from spreadsheets, transaction files, and corporate systems. There are many ways to achieve this, but some include XML, which is largely replaced by JSON, a human-readable open standard format of structured data. CSV, or comma-separated value text files, where each record is stored on a separate line and the fields are separated with commas. These standard formats make it easy to program import routines, and data can often be output in these formats, making data exchange between systems easy. Another approach is not to use manual data exchange at all, but to interface two databases together so they can read and write to each other's tables, possibly through import-export routines or possibly by a live connection. This is EDI, or Electronic Data Interchange, a protocol between two systems to facilitate the exchange of data. Popular systems might include an automatic order placement system when stock becomes low in a shop. One system you will be familiar with is the exam board system, which automatically writes results data into school information systems, to UCAS and then to universities. This can all be achieved with no human interaction. Schools can log into their system on results day and see the results already in their own database. This significantly increases the speed of data transmission and therefore efficiency of processes for users. Of course, an error in the data would also be replicated in many systems, which would be a disadvantage. There have been cases where identity data has been replicated incorrectly, and it can be hard for an individual concerned to sort out these issues.